Welcome all of you. This is another video. This is the part 2 of linear inequations that I had uploaded. I had uploaded part 1 before this. This is linear inequations part 2. So welcome all of you to another video of Maths Made Easy, and this is from 10th ICSE topic linear inequations. In the previous video I had only done a few topics, a few sums based on I had done few sums based on linear inequations, but I hadn't done the sums where you have to put the values, the solution set on the number line. So today in this video I shall show you how exactly you can put the numbers of the solution set on the number line. Okay, when the numbers are from real numbers, whole numbers, natural numbers, anything. Okay, so pay attention. There's a whole lot of new things that you don't get in other chapters that you will get here. Another thing I want to mention here, that I shall be making a separate video, since this is a board topic. I shall be making a separate video for all board questions solved. Okay, I shall be making all in that video for this entire chapter all the previous year's board questions. Few of the important recent board questions will be solved in that video. Okay, so today here I shall be just explaining the topic, and you'll know the matter and you can see those board questions for a better idea. Okay, so let us start. Represent the inequations on the real number line, that is number line for real numbers, on the real number line. Okay, so here what are these? So represent the following on the real number line. Let me take up one question here, 2x minus 3 less than equal to 6, and I shall be taking another one here. Let me take both parallelly so you get a better idea, and less than 4. Okay, so I have two sums here clearly. Now these are pretty small sums, but will give you a good idea about the number lines. And then here you make it 4x minus 6 less than equal to 6. Okay, only x to one side. Here this is 6 plus 6. This is 12. 4x. X. Now you divide with a 4. This is a 3. Okay. So this is x has to be less than 3. Okay, so inequations on the number line. Now how do I represent this on the number line? Let's see. I have taught you by putting real number values on the in set builder form, but this is real number line. Now how? Now here this is 0 and minus 1, minus 2, minus 3, and put an arrow like this. Here also put an arrow because it is going 1, 2, and then here 3, and then you can put an arrow. Now this is x is less than equal to 3. Remember, you have to draw both the sides. Don't draw only the positive. You go wrong then. X is less than equal to 3. Now if it has taken 3, see, you can see less than and equal to means it has taken 3. We will make a dark black one. There are two blacks. There are two circles that you have to draw. One is a fully covered. This is completely darkened, and one like this. Now which one applies where, we'll see. Now from here we will be darkening this, and x is less than equal to 3, and will come straight till here, till the end of it, till the arrow sign. Everything we have to darken with the pencil. So here, so this is our means, and it will not go that side. Here it will be darkened. Means what? It takes 3. When we have darkened this part at 3, it means it takes 3, and here we bring it down till the end of the arrow. That is how we show that this is x takes all the values. Now the difference between integers and real number line is, see, this entire thing is colored, entire thing is darkened, means any fractional value inside this is considered. Okay, when we go for integers and we go for natural numbers, you will see that we are taking only the numbers and coloring them. Okay, so x is less than equal to 3, color the full thing. Okay, now let me go to the second question, which is x lies between minus 4 to 4. Now there is hardly anything to solve here. I'll straight go for the this is the 0, and then here 1, 2, 3 and 4, and extend the arrow here, -1, -2, -3 and -4, and extend the arrow here, and then we have to go x is greater than -4 and less than 4, then what it is. Okay, so x is greater than -4 and x is less than 4, then what is it? So x lies between this and this, but note one thing, they have not used the less than equal to sign or greater than equal to sign. That means we cannot take -4. So empty circle. Okay, here also empty circle, and then we start coloring here. Means what it means is x takes all the value till -3.9999 anything, just, but it doesn't take -4. So it goes like this, and we color this, and here it goes. Okay, it goes till here. So here also it takes plus 3.999, but it does not take the value 4 itself. So this is how we are supposed to darken this. Okay, and so this is the answer. So this is how we represent certain inequations in the number line. Okay, right, and inequation. Now they call this as graph. Okay, for the graph. So they gave you a number line and they are saying now it's the opposite of what we just did. So write an inequation for this. Let me just see what it is. So here, starting from here, I have 0, 1, 2, 3, 4, and it goes on till here, and -1. It starts from -1 and -2, -3, -4 and -5, and it goes till the end of the line. Means it goes to -infinity. Okay, so this is how they have given the graph. Now they want an inequation for it. So here we can see x is taking all the values including -1. So can we write this? X is less than -1. Okay, and here less than equal to, note this, and x here. Now we here will not put anything else because they have not. It is just going, anything less than -1 works. So the only thing you have to be careful about is this line. So x is less than -1. Similarly, another question is here, and it goes from 2 and that side. So 0, -1, -2, -3, -4, and it goes on. 1, 2, 3, 4, and it goes on. Okay, it takes 2 and it is a dark colored 2. Okay, not an empty 2. And here it goes, this much is darkened. Okay, here this is darkened. Now what do we understand? Here x values are being taken, so x is greater than, of course it is equal to 2 also. Okay, x is greater, and where x belongs to real numbers, of course it is the real number line. I forgot to tell here because the entire thing is colored, so you have to write x belongs to real numbers. Here x is greater than 2, and you can't put the upper boundary because it is going to plus infinity, and any value greater than 2 and including 2. So I put this, and x belongs to real numbers. Now when you see a line like this which is covering all, it is a fully complete line. Okay, these are not lines which are darkened at different values of 1, 2, 3, 4. Then it is definitely real numbers. Represent on the number line. Okay, here is a question, represent on the number line, and it is 2x plus 5 by 3. Okay, and this is 3x minus 3. Represent on the real number line, real number. Now they are only telling real number line. Represent on the real number line. What to do? Okay, so here it is 2x plus 5. Okay, and then now we'll just take it there and multiply. We can do it. This is just like a linear equation. So 3 3s are 9, and this is again 9. Okay, bring all the x's to one side. So I can bring 9x minus 2x also I can do. I can take that with a change in sign, and 5 plus this is 9. So 14 here, and this side it is 7x. How much is it? Okay, x 2. Okay, so x is less than 2. Okay, 2 is greater than x. Now here there is no double line. They are not saying greater than equal to. So how should I put it in the number line? So here 0, minus 1, minus 2. Okay, since there is, and here, okay, 1, 2, 3, 4, 5, and it goes. Okay, this is the real number line, remember. So all these x values are going to be real numbers. So 2 is greater than x. Okay, means x takes any value less than 2. So here empty circle, because it is not including 2. Okay, so if you are feeling confused like this, write it like this. Okay, so x is less than 2. Now here I will color. Okay, so it is not including 2, and here it goes, here it goes, here it goes, and okay, it goes till minus infinity. Okay, if you want you can extend this side of the number line little bit. So any value of x which is less than 2, not including 2, is the solution of this sum. Okay, solve and graph the solution set. Now what is the sum? Let me see. So it is 2x minus 9 is less than 7. 3x plus 9 is less than 25. Okay, so x belongs to real numbers. Now these are not two different sums. This is the same question. Now what happens is, here I will be getting one value of x, here another value of x, and finally I will have to combine both the values and then take the answer. Means I'll have to take the basically such a value of x which will satisfy this also and will satisfy that also. So that is my answer. So here 2x less than, this is 9, this is a 16, x less than, there is no less than equal to. So that is 8. Now here 3x, this is 25 minus 9, and how much is it? That's a 16. 3x, x, this is 16 by 3. Now these are my two values of x. I am supposed to make the graph for this. That is, graph means put it in the number line. Okay. Now here I will have to draw the number line, and here I can see all positives only. So I'll make this side little less. Okay. I'll make this side little small, and I'll extend the positive side. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and 16 by 3 means what? 5 1 by 3, right? This is better to understand. Okay, now here is the arrow. Now x is less than 8. Okay, x is less than 8. So if x is less than 8, then, but it does not include 8. Okay, and x is less than 5 1/3 also. Okay, so x is not just less than 8, it is less than 5 1/3 as well. So less than and equal to 5 1/3. So here this one had permitted me all these places, but then this one is only here 5 1/3. Yeah, 5 1/3. And here I have to darken this 5 1/3. Now I can take this value because I am in real numbers. Okay, so here seeing this I am taking this, otherwise integers, natural numbers, I had to take the 5. Okay, now it is less than that. So though this equation said I can take from 8 and backwards, here this one said only from 5. So I have to restrict myself only here and then color the full thing, darken it and darken it till the end here. Okay, so here this is my 5 1/3. So this is my, and see to it that it is darkened, and you write 5 1/3 over here. And so this entire portion is the graph. Now how do I write the solution set? Now remember, if it is a real number line, we have to have solution set has to be only by set builder form. So x is such that x belongs to real numbers, comma, okay, and x is less than, okay, finally x is less than 5 1/3, okay, because finally we are taking that only. This practically loses its meaning, okay. So x is less than 5 1/3. Here you can also do it in a slightly different way, that is, you draw the same thing and 0 1 2 3, now extend this and 4 and 5 and then 6, okay, and 7 and 8, and then put the arrow. Now this place you can put two lines, okay. When you put two lines, this one becomes your 5 1/3. So you can show it like that also, okay. So same thing you do, only thing is you put two lines here to divide this portion into two parts, okay. So that is 5 1/3. So this is a more appropriate answer. So if you can do this, if time permits, please do this and not this. This is also not wrong, but then doing this would be better. Here is our next question, which is slightly different. The signs have changed from the previous one, little bit signs have changed, okay. Now here again I shall be solving it, and it becomes a 16x 8, okay. So this is one answer ready, and the second one is, this is 16, this is 16 by 3 5 1/3, okay. Now I need to make the graph for this first. I'll make the graph for it. So x is less than 8, but it is integers, not here, okay, and x is greater than 5 1/3, okay. So x is also greater than 5 1/3. Here is our graph, which is 0 -1 -2 1 2 3 4 5 and 6 7 8, okay, and arrow. Now we are going to plot integers this time. This is the first time I am plotting integers, so please pay attention. This time 1/3 has no meaning because we are in integers, so I have not made space for that, okay. And x is greater than 5 1/3. So if they say x is greater than 5 1/3, we can only take the next integer, which is 6, okay, and then it is less than equal to 8. So these are my three numbers. Note how I have darkened the circle. So we are going to start from only 6, 7 and 8. And what is my solution set? 6, 7 and 8. We don't need a set builder form for this, because we can actually put down the numbers. This is called the roster form. We can put in the roster form, okay. Okay, so here is a question. Which says the question has been given to us diagrammatically like this. This is A, okay. So here in this question, this is A, and which has been shown as, you see, note, this is another way of depicting on the real number line. Remember, they have told A and B are inequations shown on the real number line, okay. So how do we show it on the real number line? Now here, this is, you see, this is one straight line, and look at this is a curved line. Now what does this straight line and the curved line mean? Okay, so we'll first write them as they say, write in set builder form. A is equal to, A is x is such that x, okay, is such that x belongs to, first thing, real numbers, and then let's write the range. In the range, we will not take 5. So 5 is just x is only less than 5 and we are going to take minus 2. So when it is a straight line, we take that number. When it is a curved inwards line, we don't take that number. Okay, so that is x is less than 5. Okay, now let us take the set builder form for this one. Okay, now what is the set builder form for this particular inequation? Now this is the graphical form and here is B. X is such that x belongs to real numbers and then start with the range. Now see, here it does not take 3. So we will not write x is less than equal to 3. Here it did not take the 5. We did not put that in equal to sign. Okay, it is only less than 5. So it will involve 5, everything less than 5 but not 5. This will involve everything less than 3 but not 3. And this is, it is going to take this. Okay, the 4. So here it is going to take the minus 4. Okay, so these are the inequations written in set builder notation. Now if I take this, write A and B in set builder form. Okay, so this is done. Now represent A union B, A intersection B and A intersection B complement. Now many people don't understand this language. A intersection B. A intersection B means whichever element is there in E and also in B. So the set will have only those elements which are there in A as well as in B. Means in other words the common elements. Okay. Here what is the meaning of B dash? B dash is B complement. Now what is B complement? Supposing I have, so B complement are those elements which are there in the universal set but not there in B. Like if I have one universal set here, 1, 2, 3, 4, 5 and here I have set B which is 6 and 7. Then B complement is what? B complement is made up of 1, 5, 4, 2, 3. It will not include 6 and 7. Similarly here, so anything that is not there in B is B complement. So here we have A intersection, now A common with, numbers of A common with those numbers of B which are not there in B. Okay, so that is the meaning. Now we have to draw number lines, separate ones for them. So how to draw? Let's take the first one first. A intersection B. Okay, in A intersection B I will have, let's see, let's go back to the number lines. Here A and B. If you note, in A it is starting from minus 2. So I cannot definitely take this portion, that is minus 2 to minus 4 I cannot take. I have to start from minus 2 only. So here is the number line once again and 0, minus 1, minus 2, minus 3 and this side I will have 1, 2, 3, 4 like that. Okay, so here I will have to start only with minus 2 but it is definitely going to include minus 2 because B also includes minus 2, this also includes minus 2. So therefore I will include minus 2. So I'll put a straight line here and then from here I will go till the end of this, but then where will I stop? I cannot take 5, I cannot take 4, I cannot even take this region. I have to stop at 3, in fact before 3. So I will have to do this curved line and here. So this is my inequation for, this is my graph for A intersection B. Okay, note one thing, I have taken only the common area. So basically whatever is common is always including the, minimum of both. Here 3, okay, it ends in 3, cannot take 3 to 5 anymore, and here it begins with also minus 2. So the minimum, the overlap, the overlap between these two graphs is taken here. Now if you talk about the second one, which is A intersection B complement, let us first understand what is B complement. Anything outside this range, this is fully B complement. A intersection B complement. Now if you see this side, this between A minus 2 is common. Common starts from minus 2 with A. Okay, and but then A is going till 5, whereas B is stopping here. So only this much region is the B complement. Okay, so this much region is the this is B complement, which is intersecting with A. So let me now draw for A intersection B complement. Okay, so let's see. This is A intersection B and I have A intersection B complement, which is, again, this is a graph and I really don't have to draw too much of these, but I'll 0, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5 and that's it. Now here I will have to take this much region and I will have to start it from the common region. So I'll have to start with 3, okay, and that part of A which is common with B complement. Okay, so now the question arises, should I make a straight line or a curved line here? Now, does B have a straight line? No, it doesn't. Means B is not including 3. That means B complement contains 3 and that is definitely common with this. So I will take 3 and this, and here it goes. Okay, so this is my final answer for A intersection B complement. Now these sums are very much commonly given, okay, very important from the terms of ICSE. They always give these sums and they carry a lot of marks also. So see to it that you understand these sums. Now here is a sum. X is such that X, now there are two ranges marked here. Here is 1 and here is 1 and X belongs to the real number line. Okay. Now here there is something here which is an OR. Okay. Now what is an OR? OR is A union B. Means the union. Now what is union? I'll just explain that first. Now supposing I have a universal set here, okay, and so supposing here is a set which people read English newspapers and here people read Hindi newspapers. Okay, there are 7 people here, there are 8 people here. Okay, so A union B is, or let me write it as E union H. E union H is that set which will contain all these 7 people plus these 8 people. Means they can either read English newspaper or they can read Hindi newspaper. Any one of them. Okay. So total is, we'll have to put down names of these 7 and then names of these 8. That is what we call as union, and then we use OR. Okay. So here if I say and is what? A intersection H. Now if I have a universal set here and I have English newspapers, Hindi newspapers, and then here 5 people, here 2 people and here 7 people. Okay, that means a total of 7 people read English, total of 9 people read Hindi. Okay, then what is the total number of people what is E intersection H? Means they read English also and they read Hindi also. Okay, and that will come to the name of only these 2 people. So and is intersection, or is union. Okay, and when it is or, you will not have the common part all the time. You will have both the, here I can see one set, here I can see another set, both come in one number line and everything comes under the values of X. Okay, so let us now see how to draw it on a number line. Okay, so here we have, this is the number line and we have 0 and then we have minus 1, minus 2, minus 3, minus 4 and 1, 2, 3, 4 and 5 and 6. Okay, so here I have, now this is we'll have to first see this x lies does not include 0. Okay, so we'll make a blank circle here. Okay, it does not include 0, so we make a blank circle there, and it goes till it includes minus 3 because it is less than greater than or equal to minus 3. So dark circle here. Okay, darkened circle, blank circle, and I have told you this earlier that we need to color till here. That means it includes all these. Okay, come to the next part. X is greater than 2 but does not include 2. So make an empty circle here and then color it till positive infinity till the line ends. Just color it. Okay, so you'll have to do this with your pen, and this is it. Okay, so this is the answer. So this is your final number line, means x ranges from including 3 till everything before 0 and does not take 2 and goes till positive infinity. So that is the answer. So this is how we draw this inequation on a real number line. As long as they have told you x belongs to real numbers, that also should tell you that it is a real number line. Now here in this question, A they have given in set builder form and we have to put it in number line. So this is A and here is represent on different number lines. First A intersection B. How will we represent A intersection B? Now as I have told you, A intersection B is the common area between A and B. So taking the first one, which is A intersection B, let me take here. I can see what is the lowest range. This is minus 4 and the highest one is 5. Okay, so I will try to draw minus 1, minus 2, minus 3, minus 4. Okay, and 1, 2, 3, 4 and 5. Yes, so I'll try to draw this much. And now the intersecting part, means in other words the common part. So common part I cannot take from minus 4 onwards because here it is little before that. It is not even including minus 1 because you don't have the equality sign here. Okay, so here I have to go like this. Okay, at minus 1, and it will go till not even 3. It can't include 3, it has to be before till 3. So it has to go like this. Okay, so it is either like this or the other way of drawing it. I'll draw both in the same one. You will draw any one. Okay, so I'm just trying to show both in the same one here. So like this. So I'm drawing both the ways. So both are empty circles, or you color this. If you are making this type of writing, then make it like this. This is concaved inwards. Or if you make this circles, then keep this circle empty and this circle also empty. Okay, so the other one, that is the second one, A complement intersection B. So any one you should do, you shouldn't be using both. Okay, this I find the empty circle better, so let me erase that only. Okay, now A complement intersection B. A complement is that set in which none of the elements of A are there. Okay, and intersection B. So with everything outside B, what is intersecting with B? Okay, so it has to intersect with B. So here if I see this portion, it is from minus 4 to minus 1, we'll have to think. Okay, and this side, this till 5, it is in till 5 it belongs to A and B ends before that. So if I see this side, I get a common part between A and B. Okay, between A complement and B. So here again I'll write 0, 1, 2, 3 and 4, and minus 1, minus 2, minus 3 and minus 4 and minus 5. Okay, so here this is, it goes from minus 5 to, so it goes from here, see this is the portion that is there in B. Okay, and that portion is not in A. So I will darken the circle here and go till what is not in A. A does not include -1, so I can include -1. Okay, A is everything greater than -1. So this is the portion. Okay, so note the darkened circles over here. These are darkened circles. Come to the third part, which is A minus B. Now in A minus B, that is, what does A minus B mean? If I draw a Venn diagram, then if this is A and this is let's say B goes like this, then A minus B is this area. Means everything that is only an A, anything that is in B, you throw it out. Okay, anything that is in B, you just throw it out. That portion is A minus B. So A minus B will not contain any element of B. That is A minus B. So if I want to draw A minus B now, then from A, if I want to throw out elements of B, then I think I'll have to throw out if you see, I'll have to throw out from A. First I'll look at A, and from A there is, starting from -1 to, starting from -1 to 3, I'll have to throw out, because that is the common portion. So A minus B is also, throwing out the intersecting portion. So if you see, this is the intersecting portion. Actually, this is the portion I'll have to throw out for A minus B and take the rest of A. That is the meaning. Okay. So I am now drawing A minus B, where I'll throw out this portion and then take the rest of A. So if I take 0, -1, -2, -3, -4, -5 and 1, 2, 3, 4 and 5. Okay. Then I will have to take only the remaining portion. So after 3, that is, I can include 3 because that is not there in B. Okay, I'll include 3. So dark circle in 3 and I will go till 5. So dark circle in 5. So this is the portion which is A minus B. Okay, so here is my A minus B. This is A complement intersection B. This is A intersection B. Okay, so these are my 3 answers. So with that we finish with linear inequations. After this, I shall be uploading one video where I shall be taking up all the important past years board questions, ICSE questions. Okay, shall be done in that video. So you get a very clear idea as to what is asked in the boards. Okay, if you have liked the video, do not forget to like, share and subscribe. Also, you can leave a comment behind. You can ask your doubts. Okay, so I would love to interact with all of you. Okay then, that's it for today. Bye then.